Hey, what's up? Welcome to another easy LeetCode question. Today we're going to solve LeetCode 367, valid perfect square. This is going to be a very short one. You're given a number, and you should check whether that number is a valid perfect square. So how do we solve this question? Well, first of all, what exactly is a perfect square? So a perfect square is a number that's equal to the square of another number that's either less than or equal to the perfect square. We can solve this question by iterating through values less than the perfect square and then multiplying those values by themselves to see if any one of those answers would be equal to the perfect square. We can use linear search to do that, but that wouldn't be optimal since the sequence of values that are less than the perfect square are in sorted order. So we can use binary search. That would be a much faster and much more optimal approach. So we're going to use binary search to do that. So I have illustrated a number line here to help you visualize the process. So what we're going to do is we're going to iterate through the values less than the perfect square, and we're going to find the middle element. We're going to find the median value, and then we multiply that median value by itself. And depending on whether the answer we get is larger or smaller than the perfect square, the potential perfect square, then we can either move to the right of the number line or to the left of the number line. So we have a number here, 16, and then we should determine whether 16 is a perfect square. So we're going to use two pointers, a left pointer and a right pointer. I'm going to put them here. Left pointer is pointing to 1, and right pointer is pointing to 16. And then based on those two values, we find the middle element. And then we're going to find the middle element to be 8. That's the median value. Now that we're at 8, we can then multiply 8 by itself to see whether the answer equals 16. So we do 8 times 8, and that would be 64, and that would not be equal to 16. But then the answer that we get when we multiply 8 by itself is greater than 16, which means the number that we're actually looking for should be less than 8. So we move on to search on the left side of the number line because we know that we're going to find smaller numbers. So we move the right pointer to the median index, which is 8, and then we calculate a new median index, and that would be 4. And we do the same thing. We multiply 4 by itself to see whether the answer is equal to 16. In this case, it is. So it means that 16 is a valid perfect square. So how do we know that the value isn't a valid perfect square? Let's say we had something like 14, right? So if we had something like 14, we would finish iterating through the values less than 14, and we wouldn't find any value which when multiplied by itself equals 14. So then we know that 14 isn't a valid perfect square. So that's how you solve this question. And I feel like these are questions that you're only going to get in the phone screen, so it's good to brush up on those skills too. So what's the time and space complexity of this algorithm? Well, for time complexity, it's going to be O of log of n since we're using binary search. So time complexity is O of log of n since we're eliminating half the elements every time. So at first we had 16 elements to go through, then we had 8 elements to go through, and then we had 4 elements to go through. So we're eliminating half the elements every time, so it's O of log of n. Actually, since computers run in base 2, this would technically be O of log to the base 2 of n. And if you want to go in depth in the interview to explain why this runs in O of log of n time, stick around for a few minutes. If not, you can fast forward to the code. So log to the base 2 of n actually means 2 raised to some number, let's say x, would be equal to n. That's how it reads in exponent form. So there are a total of n elements. Here we already know that n is 16, so that would be 2 to the power x would be equal to 16, and then this would definitely be 4. So 2 to the power 4 is 16. And then in the next iteration would be 2 to the power 3, and that would be what? 8, you guessed it. And then 2 to the power 2 would be 4. So as you can see, we're eliminating half the total number of elements that we have to go through every single time, roughly half every single time we make a computation. So that's why binary search runs in O of log of n time. So that's it. Now for space complexity is O of 1 since we're doing everything in place. So let's dive into the code for this question. Alrighty, so the first thing we're going to do is to declare the 2 pointers that we're going to use. That's the left pointer, initialize it to 1, and then we declare the right pointer, initialize it to number, and then we're going to loop through the values less than that number in a binary search way to determine whether this number is a perfect square. So we do while right minus left is greater than 1. So this simply means that while the value of the left pointer is less than the value of the right pointer, it means that we haven't gone through all the numbers in this loop, which means that we can still continue doing computations in this loop. Otherwise, we're going to break out of this loop. So while we're here, we can calculate the median value. So that would be integer med would be left plus right minus left over 2. So this would give us the median value. And now we need to multiply the median value by itself to see what answer we get. So we say if med multiplied by med is equal to the number, jackpot, this is a perfect square. So we just return true. Else if med multiplied by med is less than the number, it means that we're looking for something bigger. So we search on the right side of the array, so we can just set left to be mid. And then otherwise, if med multiplied by med is greater than the number, it means that, I think we don't even need to calculate that. It means that we're looking for a number that's smaller, so we have to look on the left side of the array. So we set the right pointer to be equal to the median value. And if we've gone through all of this and we did not find a number which when multiplied by itself equals the perfect square, we can just return false. That should be it. I think we have to take care of a few edge cases. In cases where we might have numbers that are like 1 or 2, we already know that those are perfect squares. So we can just say if num is less than 2, we just return true. Now you might want to clarify this with your interviewer to see whether you're going to get negative numbers or something like that, and that's something you might do to strike a conversation with your interviewer. So that's pretty much it for this question. Let's run this and see what happens. There should be an if here. I always make mistakes. All right, it's accepted. Let's submit this. Hopefully it's successful. Alrighty, so for some reason it did not work. Let me try to debug this. So if we change the data type of the median value to be long, and then we typecast it to integer when we are assigning the left and right pointers to it, that could work. Let's submit this. And yeah, I think that was the problem. I am not really sure why. I feel like it's because we do have huge constraints on the values of the numbers that we're going to get. So yeah. So that's how we solve this question. If you like this type of content, please consider subscribing to the channel, comment down below if you have something to say, and smash the like button for the YouTube algorithm, and share this video around the community, and I'll see you in the next one. Bye-bye.